Hello, and welcome to this GibbsCAM Tech Tip. In this video, I will be going over how to generate OptiThreading toolpath. OptiThreading is a new feature that has been added in GibbsCAM version 25, and is pretty awesome in my opinion because it creates toolpath that moves in an oscillating motion, which enables controlled chip breaking during a threading cycle. This eliminates long stringers that can cause problems with the manufacturing process. Now keep in mind, in order to generate this toolpath, you do need to create your tool in the CoroPlus Tool Library, which does require a subscription. This is where the cutting data we need for this process is stored, so make sure you've got that squared away first, otherwise you won't be able to create the OptiThread toolpath. Now, once you've got your CoroPlus subscription set up, you can log into it while in GibbsCAM by selecting the option in the Plugins menu at the top. So I'll go up to Plugins, and then down to select CoroPlus Tool Library. That's going to open up another window, and this is where you would typically log in for the first time, but I've already done that, so we just wait a few seconds here and it will load my library. And once that comes up, I can click on the New Assembly button to build a new tool. And that's just going to load the CoroPlus Tool Library catalog. And here on the left, we've got a couple of options we can go through to help narrow down our search. And I can go choose Tool, Turn Tool, Thread Turning Tool, External Thread Turning Tool, and then just the only option within there, and that's going to narrow this down for us. And then I've got a couple of other parameters I could look at. Maybe I want to choose the direction here. I'll find the first right-handed one. There we go. And then B is the shank size, so maybe I'll find, say, 5/8. This one looks good. I'll click on this one. It's going to load some information about it. I'm just going to choose Select Item. This is going to load it into the assembly page where we can add an insert to it once it appears. And when it does, finally, we can click on the little insert icon right here. And that's going to show us that we've got 194 options for this holder. So I'm going to click on this button. And it's going to load the catalog once again, but this time just with inserts. Now there's a parameter option here where you can add filters and go in and search by maybe TPI. Choose a number there and hit apply, or even thread form type. These are usually the ones that I use. Or you can choose what style of thread you're trying to create. Or of course, you could just go through here and look at some of these parameters and pick one. I'll just grab this one right here, random, see what we get. And while it's building this model and loading the insert into it, maybe I come over here and give it a new name. Call it maybe OptiThread Tech Tip. You could even put description stuff in here, insert number, holder number if you prefer. But once you've got everything typed in, go ahead and click the Save button at the top. That's going to generate this GTC package and save our assembly. Now take note that while we wait on this to save, there's only 3 tabs available right here in this little window. But once this finishes, a 4th tab will appear, and it will be the Cutting Data tab. And that's where we can apply cutting data to this tool. There we go. Now I'm going to go to the Cutting Data tab, and of course we don't have any for this tool yet, so we can specify our own and manually enter the values if we know them, or we can get recommendations. So I'm going to click Get Recommendation, and then I'm going to build some parameters to my application here. Material type, task, which would be external thread in this case, the size of our machine, and then some thread parameters. So here on material, I've got Sandvik reference materials, but also recently used. If you go to the reference materials, these are all the families that you can search through, narrow it down, but I'm just going to go with recently used and choose 304 stainless steel. I'm doing an external thread, and I'm just on a small 6-inch chuck lathe. And now we can build some parameters for our thread. Now I can choose the standards that come with the insert in the CoroPlus Tool Library, or I can define a custom thread size, which is what I'm going to do. Now I'm going to build it based off of my part that I have here that we watched in the rendering, and it's a 2.6 nominal diameter and about 2.5 long. So one thing to keep in mind always in the CoroPlus Tool Library is whether you're working in inch or metric. So for the diameter, 2.6, it wants metric, which is 66.04 millimeters. And I'll hit the enter key and it populates both of these boxes with that. The thread pitch is always applied because of the insert. And now I need to apply a thread length, which is standard in inch. So I'm going to just enter 2.5. I'll, of course, choose a tolerance. 6G is the only one available. And then I'm going to enable OptiThreading by clicking this button here. And once you've got all of that set up, you can click on Get Results. And once the results appear, you can click Apply. And this is going to apply that cutting data to this tool. And once you've got that, you can click on Send to GibbsCAM. Now when you click on this, it starts to export, and it's going to open up another little window that lets you choose an insert direction. So this tool's going on a lower turret, so I'm going to choose this option here. Go ahead and click OK. It's going to add the tool to our tool list, build the assembly, and once that's finished, I'm going to close the tool library. You can minimize it or close it, and notice it imports the holder. No insert here, but the holder is here. So I'm going to open up that tool, and there we go. It's in a tool block in the holder that we applied for it. So now we can take that tool, drop it down on our process list, and choose a threading process. Now this is going to load a typical thread process, and you're probably familiar with definition options here from parameters and from shape. Either you want to use from parameters and apply these values here to drive your thread, or from shape and you use machining markers to apply a start and a stop. But of course now, since we're using a tool that has OptiThreading enabled, we have from cutting data, which when you choose that, it shows external threading OptiThread forward. It applies the length that we entered in the parameters. It automatically creates our number of passes. It's got the diameters locked down. So really all that's left to do is hit the Do It button. And you can see we get our OptiThreading toolpath. I'll zoom in and you can see these oscillations that are pretty exaggerated, but that's because I've got a 25 thou extra lift distance. If I put this at 0 and hit redo, you can see it's definitely not as aggressive. So you've got a little control over it, but for the most part, the tool and the tool library build the parameters and the process for us. So that's basically it, going over building a tool in the CoroPlus Tool Library and then using that to apply it to OptiThreading toolpath. If you would like to know more about OptiThreading or any other aspect of GibbsCAM, please feel free to reach out to your local reseller for more information. Thank you for watching this GibbsCAM Tech Tip. Have a great day.